All right, let's pull back the curtain on something you use every single day. I mean, probably dozens of times a day, and you don't even think about it. It's this invisible engine that's literally powering our entire digital world.
I mean, seriously, think about it. How does your bank always know your exact balance, down to the penny? How does Amazon manage to track millions, and I mean millions, of orders perfectly every single day? You book a flight on your phone, and somehow that one specific seat is yours. How does all that just work? How is it not just complete chaos?
Well, the answer to all those questions is, believe it or not, surprisingly simple. All of these crazy complex systems, they're all built on one single, super powerful idea. And that idea is the relational database. So, okay, how do you even begin to wrangle all that data? You've got customers, products, orders. It's a ton of information. Well, the very first step is actually, well, beautifully simple. You just have to get organized.
And that brings us to the big idea here. So what is a relational database? At its heart, it's basically a super smart digital filing cabinet. It's not just a messy drawer where you throw everything. Nope. It neatly organizes everything into separate tables. You can almost think of them like spreadsheets, but, and this is the important part, they have a superpower. They can all connect and talk to each other.
Okay, check out this simple table right here. We'll call it users. The real genius of this is how focused it is. It has one job, and one job only, to hold information about, you guessed it, users. Every single row is a different person, and each column is a specific detail about them. Their ID, their name, their email. It's clean, it's tidy, and it's super, super efficient.
But, you know, just having a bunch of neat tables is only half the story. The real magic, the relational part of the name, is all about how we connect these tables together. This is where things get really clever.
So let's go back to our users table for a sec. See that user ID column? That's not just some random number. It's a unique identifier. Think of it like a social security number or maybe a fingerprint. For every single user in our system, no two people can have the same one. And trust me, that is absolutely crucial for what we're about to do.
Okay, now watch how this all connects. Here's a brand new table. This one's for orders. Now it has its own ID for each order, sure, but look closely. See that? It also has a user ID column. That is the secret sauce. That's the link. When we put the number 1 in that column, the database knows, without a shadow of a doubt, that this order belongs to the user with ID 1. And who is that? That's Alice.
All right, so there are some official terms for this, and they're actually pretty simple. That unique ID in the main table, the user ID in our users table, that's called the primary key. And then the user ID in the orders table, the one that points back to that primary key, that's called a foreign key. These two keys working together, that's what creates this unbreakable superlogical link between our data.
Okay, great. So we've got these neat, organized tables, and they're all linked up. So what, right? Well, this is where the payoff is. Because we set this all up so nicely, we can now ask the database some really interesting questions and get simple, clear answers back, like instantly.
Let me walk you through a classic example. It's a super simple 3-step dance. First, we ask a question, just like a normal person would. Then, we translate that into the database's language. And finally, boom, we get back the perfect answer.
All right, step 1, the question. It's simple, it's direct, we just need to know, hey, find all the orders that Alice made. Okay, step 2. Now we got to translate that question into SQL, which is just the language that databases speak. Now, don't worry about the code itself, just focus on the logic here. All this command is doing is telling the database, hey, go connect the users table and the orders table using that shared ID we talked about, and then only show me the ones where the user's name is Alice. See? Simple instructions.
And finally, step 3, we get our answer. And it's instant. The dataset zips over to the users table, finds Alice's ID, then uses that ID to find all her orders in the orders table, and then it just hands us this perfectly combined piece of information. This right here, this is the whole point. It seamlessly pulls together data from different places to give us one simple, totally accurate answer.
So you can see how this all works, right? It's pretty neat. But the bigger question is why? Why has this one model been the absolute bedrock of basically all software for like decades?
Well, it really boils down to 4 huge benefits. First up, you've got consistency. Since you're not copying the same information all over the place, your data stays accurate. Then there's flexibility. We just saw this with our SQL query. You can ask pretty much any question you can dream up. Third, and this is a big one, is integrity.
Those keys we talked about, they make sure the data actually makes sense. You literally can't create an order for a customer who doesn't exist in the system. And finally, scalability. These things are built from the ground up to handle millions or even billions of records without breaking a sweat.
And look, this isn't just some abstract concept. These are the real-world workhorses of the internet. Ever heard of MySQL, PostgreSQL, Oracle, or SQL Server? These are the powerhouses running behind the scenes of pretty much every bank, airline, and online store you use every single day.
For literally decades, this structured, logical, and just incredibly reliable system has been the foundation that our entire digital world was built on. It's really the unsung hero of the internet age, for sure.
But here's the catch. This whole system works beautifully when all your data can be tucked away neatly into tables with rows and columns. So what happens when it can't? What do you do with the messy, chaotic, unpredictable data from something like a social media feed or a giant network of sensors? Well, that, my friends, is a story for another time. Join us for our next explainer, where we're going to dive headfirst into the wild world of NoSQL.